Hey, today we're going to cover section 5.3 and multiply radical expressions. In this video, we'll go over the definition and then we'll do problem number 1. Notice you have the nth root of a and the nth root of b. And remember, n is greater than 2. So we're talking about square root, cube root, fourth root. We're moving on. Then you can mash them together or separate them. As long as you have the same index, you can put them together under one root, or you can separate them into different roots. This is helpful when we're trying to simplify and multiply radical expressions. Let's see how. Look at the example of the square root of 8 times the square root of 36. If you break that down into the prime factors, you'll see I have 3 2's and then 2 2's and then 2 3's. If you put it all together, then you can look for your groups. I have 2 groups of 2 2's and then 1 group of 2 3's. I can see what I can take out, both of those, and the 3, and then what's left is just the 2. If you wrote this as an exponent, so you could start out with 2 cubed, and this would be 2 squared and 3 squared. So if you were to put that all together, you'd have 2 to the 5th, and then you would take 2 to the 4th out, kind of like what we looked at before. Then you multiply the numbers in front. 2 times 2 times 3 is 12, and you've simplified this to 12 root 2. What about the 5th root of 16a cubed and the 5th root of 8, a to the 4th? If you break this into primes, notice you only have 4 2's. I need another 2. That's the case when mashing them together would be helpful. So if you mash this all together, I can think about this as 2 to the 4th power, a to the 3rd power. Then I take the 5th root of 2 cubed, a to the 4th. If I start out by mashing them all together, I have the 5th root of 2 to the 4 plus 3, right? So 2 to the 7th, and then a to the 3 plus 4, also a to the 7th. Now that I mush them all together, I can group them the way I want according to the index. So I take out group of 5, and we can see that written out here. Take out the 5 2's, take out the 5 a's. So we talked about this before. When you have one big radical, you could write 2 radicals and split it up into what can come out and what has to stay. What can come out is 2 to the 5th and a to the 5th. What's left, or what has to stay under the root, would be 2 more 2, so 2 squared, and 2 more a, so a squared. And then you can simplify. So this would be 2a, and this would be the 5th root of 2 squared, which is 4, and then a squared. So that's what we get here. Let's try some more practice and see if we can figure out what's going on here as we multiply these radicals. Okay, same idea. We're trying to simplify, so we can take this whole piece and split it up into what can come out and what has to stay in. But I'm not quite sure about the 16, so change it to primes. 16 is, oh, that's 2 to the 4th. Okay, so that can be helpful. I have the 4th root of 2 to the 4th, and I have x to the 4th. Both of those can come out because 4 and 4 are both divisible by 4. So this just gives me 2x, and you're done. You could write 2 times 2 times 2 times 2 and realize you have that 4 group. All right, let's take a look at B. I have 125a to the 2/3. So if I think about that as a radical, remember that's the cube root of 125a quantity squared. Now, 125, if I break it down to primes, is 5 cubed. So I have the cube root of 5 cubed a, but that whole thing is squared. So let's go ahead and get rid of the parentheses by distributing the 2, which means I'll have the cube root of 5 to the 6th, 3 times 2, and then a squared. Remember, you're looking for exponents divisible by the index. So 6 divided by 3, oh yeah, I can take all of that out. 6 divided by 3 is 2, so I'm left with 5 squared. And then underneath the cube root, I still have a squared because there's not enough a's to take any out. Then I simplify 5 times 5, which is 25, and I get 25 times the cube root of a squared. You can put this back into fractional exponent format. If that's how they started, maybe that's how they want to finish, and that's completely fine. So when I'm done, I will have 25a to the 2/3. All right, let's look at C. Here we have 5 out front, so we're just going to leave it there. And then we're taking the square root. Remember, you can think about making 2 pieces. What can come out and what has to stay in. When I think about 12, that's the perfect square of 4 times 3. And then I think about x to the 7th. I've got to divide that by 2. What kind of grouping could I do that could be divisible by 2? Oh, okay, x to the 6th times x. Okay. Because 6 plus 1 is 7, and 4 times 3 is 12. So when you're simplifying, you can kind of make 2 buckets and see what can come out of the root and what has to stay under. I leave this 5 out, and then I'm going to multiply by the square root of 4, which is 2. Remember the exponents you divide, so 6 divided by 2 is 3, so times x to the 3rd. And then I still have the square root of 3x. So when I clean that all up, I get 10x cubed times the square root of 3x. Great job, you guys. Let's do D. Here, maybe I want to mush these together so I can figure out what's going on. If I break this down to primes, 15 is 3 times 5, and I break 35 down to primes, that's 5 times 7. There's no pairs because this is the square root, so I want 2 things multiplied together. If you leave them separate, there's no pairs. But if you put them together, there's 2 5s. That's awesome. So the first thing you want to do here is multiply 3 times 7, which is 21. And then you could list your primes in order if you want, under all of them under one root. So 3 times 5 squared times 7. Now I see I can take that 5 squared out. So if I go back to this mentality, what can I take out? What has to stay under? I know I have 21 outside. I can take this 5 squared out, so multiplied by 5. And what stays under is 3 times 7, which is 21. And then you can go ahead and simplify 21 times 5. So 105, and then the square root of 21. All right, let's keep going. Look at letter E, 175 y to the 8th, and we're talking about the square root. So once again, you could think about what comes out, what stays in. Okay, y to the 8th, I know I can divide that by 2, so I'm set. But what about 175? 175 is 25 times 7. Now I take the square root of 25, which is 5, and I divide 8 by 2 to get y to the 4th. And then what I'm left with that has to stay is the square root of 7. Let's try that process again for F and for G. All right, I'm talking about the cube root. I'm trying to make 2 roots, one that can come out times one that has to stay. Remember to use the index of 3, and they're all exponents. There's no kind of coefficients here, so I don't have to worry about thinking in that way about the big numbers. I just think about dividing. I want to divide by 3. Is 6 divisible by 3? Yes. Take all the a's. Is 7 divisible by 3? No, but I could say b to the 6th and then leave one more b here. What about 13? I could say that could be c to the 12th, and then there's one more that has to stay. Now I go ahead and divide to take those out of the root. So 6 divided by 3, so I get a squared. Another 6 divided by 3, so b squared. And then 12 divided by 3, so c to the 4th. And then what's left is, don't forget the cube. You got to have that third index, cube root index, BC. Good job, you guys. I hope you're kind of getting this puzzle, figuring it out. Let's try a couple more. Look at G. Should we mash them all together and then clean them up into the two buckets? Let's try that. I have 3 out front. And then if I put all the numbers, it would be 2 times 10, which is 2 times 5. Then I want to count the x's. So 5, 6, 7. 7 x's, and then I count the y's. So 1, 2, 3, 4, 5, 6. Awesome. Mash it all together and then clean it up. I have this 3 outside, and then what can come out and what has to stay? I have 2 2's, so you could say 2 squared or you could write 4, whatever you like best. And then you have a 5 that stays. What about x to the 7th? I'm trying to divide that by 2. How can I make groups? So if I do x to the 6th and x, that's divisible by 2. Remember, you want the most you can take out. So you wouldn't say x to the 4th and x cubed. That would just be messy. Take everything out that you can. All right, now look at the y's. That's to the 6th power, which is divisible by 2, so we're set. Then you go ahead and take that out of the root and you're done. So I have 3 and then times 2 and then times x to the 6 divided by 2 is 3 and y, another 6 divided by 2 is 3. And then I have the square root of 5x. The last piece is multiply 3 times 2. So the final answer, 6 x cubed y cubed times the square root of 5x. All right, let's do h. They're both fifth roots, so I could mash them all together and then clean them up. 18 is 9 times 2, so that would be 2 times 3 squared. And 81 is 9 times 9, so that would be 3 to the 4th. Then I count my m's, 3 and 3, so m to the 6th. And then I'd count my n, 2 and 3, so n to the 5th. Okay, I have these all mashed together, and now we can also kind of mash that 3. So 4 plus 2 is 6. So 3 to the 6th power. Get them all in one piece. Now I can split up into 2 fifth roots to see what can come out and what has to stay. There's only 1 2, so that's got to stay. And I see 3 to the 6th, so I could put 3 to the 5th here, and then I'd have 1 more 3 to stay. M to the 6th, same thing. M to the 5th, and then 1 M has to stay, and then N to the 5th can come out. Now I go ahead and divide all of these by 5, so I'm left with 3 M N, and then what's left under the 5th root? Don't forget the root. So 2 times 3 is 6, so 6M. Thank you for being here today and working through those problems. I hope it clarifies, and I hope you have the best time doing it. See you later. Bye.